At the observatory in Meudon, several miles from Paris, as soon as the sun appears from behind the clouds, there is a rush to study it. It's been the same story every day for more than a century. First, the shed slides on its rails. Then a strange appliance appears. The mirrors are checked. The first, then the second. The sun's rays are then captured and analyzed by this spectroheliograph. This age-old technique remains the perfect complement to the high-tech solar probes.
Solar Orbiter and Solar Probe are both very short missions in terms of duration, whereas here, with the spectroheliography, we can study the Sun in the way it's been studied for 110 years. That means we have this very stable reference, which allows us to compare observations.
1908. 110,000 shots of the Sun have been archived in these boxes. This is the world's longest-standing collection of photographs of the Sun. These glass plates reveal big black spots which appear or disappear depending on the day. For thousands of years, the Sun was thought to be an unchanging star which revolved around the Earth. That all changed in 1610, when Galileo directed one of the first ever telescopes at our star.
From his observations of these sunspots, Galileo showed that it was an evolving star, which changed daily, and that these spots moved and were more prevalent on some days than others. He realized that the Sun was, in fact, an active star, a living star, which changes every day, if not every minute.
Today, the best Earth-based telescopes provide us with spectacular images of the surface of the Sun. We can see matter that is in a state of perpetual turbulence. These incandescent granules appear and disappear again in the space of just 8 minutes.
It's almost like boiling water, convection. So the stuff is coming up from below and it is creating these granular patterns.
It's like it's boiling, but in an unfamiliar way. It bubbles up in a way that's unlike anything we see on Earth.
This boiling matter is essentially hydrogen and helium, but not in the form of the gases found on Earth. At this temperature, they're in the form of plasma, the fourth state of matter.
Everyone is familiar with solid, like ice, water that is flowing, and then a vapor of steam when you superheat the water. If you continued to heat and heat, it would actually dissociate into what it's really made of. So it's made of ions and electrons, and that's what we call a plasma.
The constant movement of this plasma inside the Sun creates a vast magnetic field, 1,000 times more powerful than the Earth's magnetic field. That's what causes these black spots to appear. The size of them is staggering. This spot could engulf the Earth 10 times over.
They appear black because the magnetic field is so strong in a sunspot that it basically inhibits the heat and the light to go across it. However, they're not black. If you took it away from the sun, it would appear somewhat bright. So that it's just relative to the very, very bright surface around it, you can't tell, and it looks black.
Also, in the Sun's atmosphere, the magnetic field governs everything, including these solar flares. They are like magnetic storms.
Sometimes the magnetic fields interact and they create these explosions like solar flares.
The most powerful telescopes on Earth show us the surface of the Sun and these huge black spots with amazing precision. But they are incapable of showing us images of the Sun's atmosphere.
These superb images of the Sun's corona, with its loops and its bright patches, which are evolving all the time, are impossible to capture from the Earth. Satellites are essential for observing these phenomena.
Going beyond what satellites are currently capable of, the engineers working on Solar Orbiter have devised an exceptionally high-resolution camera that will be able to capture solar flares and perhaps even discover hitherto unknown phenomena. In Orsay, near Paris, Frédéric Orcher's team is in charge of one of the cameras on board Solar Orbiter.
We've been developing this instrument for 15 years, so we feel very emotional about it. We're going to see it on top of this rocket being launched into space. That's bound to be extremely moving.
Atmosphere is active.
This scientist also worked on SOHO, a satellite launched in 1996 that is still active today. Images captured by SOHO and its counterpart, SDO, have revolutionized the way we see the Sun, finally revealing its mysterious atmosphere. Only telescopes based in space can capture these images, because the Sun's atmosphere is so hot that its light is invisible from the Earth.
A lot of the interesting is that things that the sun produces do not emit radiation in the light that we usually see, but emit radiation in the ultraviolet and X-rays, and that's absorbed by the Earth's atmosphere. So you have to go into space to be able to see the active sun.
These images are achieved using a precise ultraviolet spectrum. A bit like with a scanner, they reveal the actual structure of these flares. Magnetic loops constantly crashing into one another. But a single ultraviolet wavelength is not enough to capture everything.
The sun atmosphere has a lot of layers, and you can't really see everything unless you're viewing in different wavelengths. And so it allows you to see different layers of the atmosphere.
Depending on which layer you're observing, you observe different phenomena. And if we combine these observations using different colors, we can reconstruct the life of these structures, these flares, and see how they evolve, how they're triggered.
In order to capture each of these different sides of the Sun, the camera on Solar Orbiter is equipped with extremely fine filters. Scientists will be able to go from one filter to another using this motorized wheel and reconstruct these solar phenomena in 3D to reveal all their secrets. And this image will be all the clearer for the fact that this camera has a resolution that is 4 times higher than on the best space-based telescopes such as SDO.
Solar Orbiter will be able to see about 100 kilometers of the Sun, which is the equivalent of seeing a grain of rice from a distance of 2 kilometers.
Thanks to this exceptionally high resolution, Solar Orbiter might even discover previously unknown phenomena in the Sun's atmosphere.
Every time we look at the sun with higher resolution, we see more things. And the reason is that the magnetic field is stratified and has structure at very, very, very small scales.
The unique orbit of Solar Orbiter will also allow it to film regions of the Sun that have so far never been seen, namely the poles. Observing them could throw up a few surprises.
As we've seen before from other planets, unexpected shapes of vortices can occur in the polar region. At the poles of Saturn, we find that there's a vortex which has a perfect hexagonal shape. So we usually find things that are unexpected. It's very rare that we can predict what will happen in a region that we've never explored before.
The European and American solar missions will allow us to take a leap into the unknown. A greater understanding of the Sun will mean a greater understanding of the cosmos.
These 2 missions will really unlock a lot of the mysteries that we've been dealing with for decades now. And
It's a fascinating topic containing fundamental secrets that are useful to understand the universe as a whole.
These missions will go well beyond the surface of the Sun, helping us to understand the effect that this imposing star has on us. Our star might be life-giving, but it is also life-destroying. This is a crucial step in our search for extraterrestrial life.